So you guys finished quiz number 6. Now let's go over these answers to the questions here. Number 1, it says a cosine double angle formula is as follows, and you have cosine of 2x equals cosine squared x minus sine squared x. Well, that is an identity. It says use this identity along with the Pythagorean identity for trig, and then says where to find that. So what I'll just write out here is that identity I asked you to go and look for. So cosine squared of theta plus sine squared of theta equals 1. This is the really famous Pythagorean identity for trigonometry. One of the fallout equations of that would be cosine squared of theta equals 1 minus sine squared theta. So I'm going to use this along with this given, do you see this given formula right here? So I'll use this formula and I'll use this equation to get this new formula right here. So it's just a couple of steps. Let's write it out. So let's start out with cosine squared x minus sine squared x. So I'm starting out with the right hand side of the given formula. And what I want to do is I want to replace cosine squared x with 1 minus sine squared x. So after I've replaced that, then of course I'll just write the rest of the expression. So as you can see, if I remove the parentheses, I have exactly what I needed, and that's cosine squared x minus sine squared of x, but this would be 1 minus 2 sine squared of x, and then I have the formula that I was asked to derive. Okay, so I'm done with problem number 1. Problem number 2 is another identity. It tells you where to begin on the left-hand side and where to end on the right-hand side. So on the left-hand side, I'm just going to begin with replacing tan of theta with its identity, which is sine of theta over cosine of theta. By returning to sine and cosine, you are very likely to have some good cancellations. So that's what I'm doing here is every time I see a function that's not sine or cosine, I replace it with an identity for the translation back to sine and cosine. So here's my new numerator. The denominator secant would turn into 1 over cosine of theta. So all of these identities are given in the book in section 1.4, and it's important for you to know them. So the next step here is just to observe what we've got and see if already do you have anything that you could cancel, and you do. You have these signs will cancel because they are numerator and denominator the same. So I'll rewrite now what I have. In the numerator, I have 1 over cosine of theta. Now, in the denominator, I have a subtraction problem that I really should perform. In order to perform it, I do need a common denominator, so I'm obtaining that here. 1 turns into cosine over cosine. Okay, notice that this is subtraction. I do need to subtract now, so keeping the numerator as is, I'm just dealing with the denominator here, and I will subtract. Well, when I subtract, I can't actually subtract 1 minus cosine of theta and come up with anything better, so I'll just write it, but now I have a common denominator. This is called a complex fraction, and so with a complex fraction, I just multiply by the reciprocal of the bottom. So the reciprocal is cosine of theta over 1 minus cosine of theta. And good news is that my cosines here cancel, and this is the last step because I'm obtaining the right-hand side that I needed to obtain, and I have 1 minus cosine of theta. Okay, so problem number 2 is done. Problem number 3 involves a sum or difference formula, and so this was an open book quiz, so you're free to look back at your textbook. So in your textbook, it gives you the formulas. This is a sum formula, and it says that sine of A plus B, and it says in your book, is the exact same thing as saying sine of A cosine of B plus cosine of A sine of B. So I'm going to use this formula, but I have this angle 5 pi over 12, and I don't know anything about over 12 type of variety. I know a lot about over 6 and over 4, but not over 12. So this is posing some difficulty, but instead what we'll do is we'll write it as a sum. So if I think of adding up a couple of fractions that have a denominator of 12, I would get a denominator of 12. I'm just going to split up 5 pi, and so one way to do that would say 3 pi plus 2 pi, and that would give us 5 pi. So notice that this is good luck because my guess here is providing me with a new fraction that I know a lot about, and that is pi over 4. So I'm going to use only radian values that are really familiar to me, and in order to do that, I would need this cancellation that I'm getting right here. So instead of saying 3 pi over 12 plus 2 pi over 12, I'll say pi over 4 plus pi over 6. So I'm going to come over here, and once again, instead of 5 pi over 12, we just write pi over 4 plus pi over 6. Now notice that this gives me, through the formula above, it gives me the game plan. So I'm supposed to take the first angle and put that in this spot. I'm supposed to take the second angle and call it B and put it right after cosine. Then I go to cosine and notice that the first angle once again would be written right in that spot, and the second angle, we'll call it B, is pi over 6, and I'll put it right there. So here's what we have is a lot of familiar values. We've seen these before, and once again, you do have to have these radian angles memorized, and you should be able to just, say them off the top of your head. So sine of pi over 4 is equal to root 2 over 2. And cosine of pi over 6, what does that equal? It's root 3 over 2. And cosine of pi over 4 is root 2 over 2, whereas sine of pi over 6 is its value is 1/2. So all that's left for me now to do is just do the arithmetic on these fractions, multiply top to top, square root of 2 times square root of 3. So I'll write that as the square root of 6. And the bottom 2 times 2, when you multiply, you have to multiply across the top and across the bottom. The result of that, this fraction times this fraction, would go like so. We do have a common denominator, so you don't even need to find one. So it looks like I'll just put the numerator in condensed form this way. Notice that this is not equal to the square root of 8. So if you have two separate roots, I can't combine them. This does not equal the square root of a plus b. So don't be tempted to say this is the square root of 8. Rather, this is your final answer. This is as far as you can go. So we've finished number 3. Okay, looking at number 4, notice that you have sine, cosine, cosine, sine. This is a difference formula. So if you look in your book, you would find that sine of A minus B equals the formula that you're seeing there. That is sine of A cosine of B minus cosine of A sine of B. So all that I have to do now is translate what I'm seeing here back to a subtraction of the arguments. So the subtraction of the arguments would be x minus 4x. All right, well, that would be sine, and you would get a negative 3x. All right, then there's another hint here, and it says, also use the fact that sine is an odd function to simplify. So in odd functions, the negative, so I'm just going to highlight this here, in an odd function, the negative inside of an argument pops out to the outside of the function. So this is negative sine of 3x, right? Okay, so I'm supposed to graph this now. It says go ahead and graph this. So the graphing goes like so. You go 1, 2, 3, 4, 5, 6, 7, 8. So we step out 8 spots, and we note that the period has changed. It is not just your regular 2 pi. It's not the regular 2 pi period, but rather notice the 3 here is changing the period. So we have a new period of 2 pi over 3. The end of the period goes at this very last tick mark on the cycle, and I'll just put that there. Okay, the 8th tick mark is the last of all of my tick marks. Now I mark the other ones. I go in halfway. 1, 2, 3, 4. Okay, what's halfway? What's half of 2 pi over 3? Well, the 2's cancel, and yes, half of 2 pi over 3 is pi over 3. So I have pi over 3 right there. Okay, go halfway in again. What is half of pi over 3? So then the rest of this here would just be shown as pi over 6. So we'll have pi over 6. And then over here, what's the last one right there? This is 1 pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2. So I have my tick marks marked there. I'm going to just go up 3 spots here. I'm going to call this 1, 1, 2, 3. I'll just go down here. I'll call this -1. And now what I'll do is I'll make a sketch of the graph, noticing that I have a reflection. So it starts baseline, we go low, we go baseline, go high, and then go baseline. So once I've made my critical tick marks, then I just now follow the marks, and I'm creating the sine graph here over one cycle. Fantastic. I am done with that. Okay, looking at number 5, the very next one, we have that cosine of b equals the square root of 6 over 5. So what I need to do is come up with the double angle. So cosine of the double angle, this I'm going to just use the formula that says 2 cosine squared of beta minus 1. This is in your book. This is a formula. So what I will do here is I'll recognize that I was given cosine of beta as the square root of 6 over 5. I'll square it, and then I'll just do the arithmetic on this. So when you square a square root, you just get 6. When you square 5, you get 25. And then we need to ultimately subtract 1. So I have 12. That is 2 times 6. Remember, this is 2 over 1. 12 over 25 minus, and then I would say 25 over 25. Okay, so what I'm getting here is a negative value, and it's negative 13 over 25. Okay, and that's my answer. I'm all done. Okay, on to the next one here. You have cosine, or sine is given to you, and you need to find the double angle formula, or the double angle sine of 2 theta. So the double angle formula is this: 2 sine of theta, cosine of theta, and I'm only given one of these, so I do need to find the other. So I'm running out of time here, and I'm going to continue this in the next video. But here's what I need to do is I need to throw this in here. However, I don't have the value of cosine, which I need to find. Okay, so that will be continued in the next video because I only have these little 15-minute videos. So you'll see that in the next video, and I'll finish up the rest of the problems.